Good morning and welcome to Python for Data Science by Utkarsh Minds. Let us continue from our previous exercise. We had seen yesterday how to implement the Pearson chi-square goodness of fit test. A brief recap is the goodness of fit test will be applicable on nominal data or one sample nominal data. Nominal means the variable is like place of residence. This place of residence can take any city like India, like Bombay, Delhi, Sydney, Paris. So there is no order in these cities. They are simply names. There is no mathematical operation possible on them. Such kind of data is nominal data. Another example is which pet do you have? So it can be cat, dog, parrot, fish. So there is no order in this. They don't have any mathematical operations. We cannot compare them. So this kind of data is nominal data. Today we will see the effect size of the goodness of fit test. The effect size is known as the goodness of fit test. Effect size is known as Cramér V. So we will work on a data, apply the goodness of fit test, and then we will calculate the Cramér V effect size. So I am reading the data in my Colab notebook. The name of this data set is GSS 2012A. It is a common survey data. This one has 194 rows and 706 columns. So I am just taking one column from this which has nominal data. It is the MAR1 column. I will get my value counts, which will give me the number of values, or this number of values means the options and how many times are these options occurring in the data. So married is occurring 972 times. Never married is occurring 395 times. The research question is, are people more likely to get married? Okay, I am noting the research question here. I will call it RQ. So are people more likely to get married? There will be a null hypothesis which says there is no preference and the distribution of each category is same. Alternate hypothesis is the opposite of this, so I will copy. There is a preference and the distribution of each category is not same. And now to apply the chi-square from SciPy library. So that is in chi-square, and in this chi-square I will pass my table, this one, which will generate the p function, p value, which is the probability, and it will generate the chi-square statistics. So these two I am saving as statistic and p value. The p value we have seen in our previous class. What is the importance of this p value, what it means, what is significance of result, what is the meaning of null hypothesis rejected. So today we will focus only on the Cramér V effect size. So Cramér V, which is the effect size. For that we have a formula, which is, I will take my statistic, I will divide it by n multiplied by df and take the square root of this entire value. So n is the sample size. Sample size is calculated from the data frame, the number of rows in the data frame, and df, the degree of freedom, is calculated as 1 minus the number of categories. So there are 5 categories, so that will be, n will be 4. Okay, I am writing here a note that n is samples and df is number of categories minus 1, and that gives us the Cramér V effect size, which we are getting here as 0.3977. We can interpret this. To interpret this, there is a table in the Statistical Power Analysis for Behavioral Sciences book. That table we will have to follow to understand whether the effect size is interpreted as negligible, small, medium or large. What the effect size means is that there is a difference in the distribution of each category. That means all the 4 categories are not evenly distributed. There is a difference, but how big or small is the difference, that we understand with effect size. So for that we can, usually the rule is, if the degree of freedom is k, that means if degree of freedom is k, then from negligible, so the chart for interpretation says that from 0 to 0.1 divided by square root of k minus 1, that is negligible effect size. From this range to this range it is small, from this to this it is medium, and this and above is large. So we can create a formula for finding out where is this line, and based on that we can get an interpretation about the effect size. At the end, our conclusion will be that in the population the different categories are not evenly distributed. For that we used as per the Pearson chi-square goodness of fit test. P value, we can say P is less than 0.01, and the difference in the categories is, so that we will get from this interpretation. So that is ... because the Cramér V is 0.397. In this way we will understand we will document the result of this hypothesis. test. So that was it about goodness of fit test, how to perform it in Python and how to calculate the Cramér V effect size. We will continue with the next hypothesis test in the following video. Thank you for watching. Take care.